Gr10s, and welcome to the second and pretty much last lesson where we'll be covering new formulae for analytical geometry. First things first, I'd just like to remind you that analytical geometry can actually be called coordinate geometry. So if you by any chance use a study guide or see another revision paper, analytical and coordinates are synonymous for this type of geometry. I actually prefer the term coordinate geometry because we're dealing with coordinates on the Cartesian plane. So this little sketch in front of us is going to be used to determine the midpoint formula. Now let's have a look. This letter M is the middle point on the line AB. So that means the distance AM is going to be exactly the same as the distance MB. Now let's think about how would we calculate this midpoint. First things first. Let's drop down to the x-axis at the point A and realize that that value on the x-axis would be number 1. And at B, the value on the x-axis would be 6. Now let's try to be as logical as possible. If we were to think about the middle value between 1 and 6, that value would connect up to the point M, which is the midpoint of AB, and it would give you the x-coordinate of M. Now how do we find the middle value of 1 and 6? Think about it in terms of averages. If you add 6 and 1 together and divide by 2, you will get the midpoint. So that point on the x-axis right there is 3, 5. Likewise, if we connect the y value, the y coordinate of the point B to the y-axis and the y coordinate of the point A to the y-axis, we can then find the middle value between that 4 and that 2. I'm sure it's very easy for you to see that halfway between 2 and 4 would obviously be 3, but let's just do some maths to double check. What would the y value of the coordinate M be? We would add 4 and 2 together and divide by 2. We are finding the average between 4 and 2. Voila, that would give us 3. And so now we have the coordinate of M, which is the midpoint of AB. Note the notation. I use a capital M for midpoints, and you can use this subscript to clarify which line segment you're working with. So M means midpoints and AB means that we are dealing with the midpoint of AB, which is this coordinate right here. Note that the midpoint of two coordinates is merely the average between the x and y values, and a baby small m is used for gradient. So if we find the average between two x values and the average between two y values, we get something called the midpoint formula, and that is in red. Write it down and please, please, please. A really straightforward, easy application of the midpoint formula, where we have to calculate the midpoint of the line segment joining these two coordinates. Right, I haven't labeled the coordinates A and B, but you can do that to help yourself. So now we have a value that corresponds to the x value at A, the x value at B would be -1, the y value at A would be -1, and the y value at B would be +3. So if you'd like to sketch this on a set of axes to just visualize it, it may be easier for you to see. So I've plotted the point 4 and -1. It would be more or less there on the Cartesian plane, and the point -1 and 3 could be more or less there. And then that blue dot represents the midpoint. So this distance between this black dot and that blue dot will be equal to the distance between that blue dot and that black dot. Okay. And by dot, I obviously mean point or coordinates. So that blue point right over there, we can be calling the midpoint, capital M for midpoint, subscript AB, because the line segment is AB. And now let's just whip out our formula. Note that this formula is the strangest formula you've probably seen, because this formula resembles a coordinate. It has a semicolon in the middle, which means that to the left of the semicolon is the x value of the coordinate, and to the right of the semicolon is the y value of the coordinate. Let's substitute in those relevant values. X value at A, we saw up here, is a 4. X value at B, we see is a negative 1. 4 plus negative 1 is going to be divided by 2. Then we're going to take the Y value at A and add it to the Y value at B, negative 1 plus 3 divided by 2. Simplify each of those fractions and you'll get the coordinate values of the midpoint of AB. Note that you could also be asked to find the distance of AB. So we have two coordinates, we can apply the distance formula. And if you remember grade 9, you can also apply the gradient formula of the line AB, which is, I hope you remember, change in y over change in x. So you take 3 minus 1 over negative 1 minus 4. So I think that would give you 4 over negative 5. Negative 4 over 5, and that makes sense because if you were to walk left to right along this line, we would be going downhill. It is a negative gradient. So please keep in mind that all three of these concepts, midpoint, distance, and gradient, will be tested or applied together. The second example is also merely applying the midpoint formula, but I want you to realize that the midpoint formula, because it has that semicolon in the middle, it can be split into two mini formulae. And that would look like this. So I've written down the midpoint, and then I've split it into two halves. The first half is the x value of the midpoint equals the average between the two x values. And then the other half of the midpoint formula could be the y value of the midpoint. So note that you can work with these two separate mini formulae when faced with a question like this one. Determine the values of x and y if c, which is negative 1 and negative 2 as your x and y coordinates, is the midpoint. So we have been given the midpoint. In other words, we have the x value of the midpoint, which is a negative 1, and we have the y value of the midpoint, which is a negative 2. What else do we have? We have a full coordinate. So we have the x value at A, which is negative 3, and we have the y value at A, which is negative 4. So this means that we have 1, 2, 3 unknowns, but 2 pieces of information for this mini formula here, which means that we can solve for the x value at B. And that is exactly what the question is asking us, because it's saying determine the values of x and y, and B is the coordinate x, y. So likewise, we have 1, 2, 3 parts of this mini formula. 2 out of the 3 parts can be substituted with specific numbers, and so we can solve for the third unknown, the y value of B. I've substituted in negative 1 from here into the x value of C. Negative 3 from A is substituted into the x value at A, and to get rid of the fraction, I multiplied both sides by 2 and isolated x to get x equals positive 1. I know you may not like the way this looks. If you just took your 3 to the left-hand side, you would get negative 2 plus 3, and you would get 1 equals x, which is exactly the same as what I've written. So let's do the same for the y value. Substitute in negative 2 as the y value from the midpoint, which is C. Substitute in negative 4 as the y value of A, and solve for y, and you will see that y equals 0. So the coordinate B must be 1 and 0. We have solved for x and y. A little sketch just to represent this, to see that it can actually make sense to you, is if you were to plot A and C, and then B would have to be equidistant. Note that new word, same distance. A midpoint C is equidistant from A and B. So it's the same distance from A and B. That's what this would look like. Last example for the day involves a parallelogram. Remember that a parallelogram is a type of quadrilateral, and a quadrilateral is a four-sided figure. So we have given you the coordinates of this parallelogram, and now you need to prove that it is indeed a parallelogram. So at this stage, we can't make that assumption. We need to go over our properties of a parallelogram and see, do the properties of a parallelogram apply to this sketch given? Well, what are the properties of a parallelogram? What do you know about the opposite sides? Yes, it's in the name. They are parallel because it's a parallelogram. So when we're looking at coordinates like the line DC and AB, we know that they parallel to each other, and BC will be parallel to AD. Tell me something about those gradients. I hope you said it. Opposite gradients will be equal to each other. So if you have to prove that this given quadrilateral is in fact a parallelogram, if you can show me that the gradient of BC is exactly the same as the gradient of AD, as well as DC having the exact same gradient as AB, then you've proven that the opposite sides are parallel. And so ABCD must be a parallelogram. How else could we prove that using these coordinates, how else could we prove that this quadrilateral is in fact a parallelogram? What about the distance formula? Because opposite sides of a parallelogram, you know, are equal to each other. So if you go and find the distance of BC and then the distance of AD, they should be the same. The distance of CD should be the same as the distance of AB. And if you have two pairs of matching distances, we can conclude, or we have then proven, that quadrilateral ABCD is a parallelogram. Then last but not least, and this is my favorite one, the properties of a parallelogram state that the diagonals of a parallelogram bisect each other. Now, what does it mean to bisect? It means to cut smack bang in half. So that means, doesn't the word bisect link up to the concept of a midpoint? If you were to take the diagonals AC and the diagonal BD, you could find the midpoint of that line segment AC, and you could find the midpoint of that line segment BD. And if the midpoints of each of those diagonals give you the same value, then this quadrilateral is a parallelogram. And this, my dears, is the quickest way to prove that a quad is a parallelogram. Note the abbreviation of a parallelogram is and then just an M. Parallelogram. So we often call it a palm. I know it sounds strange, but a parallelogram can be shortened to palm. So the quickest way to prove that a quad is a palm, you just find the midpoints of the diagonals. So that's what I'm going to do. All three of these methods will work, but this one in the red rectangle is the quickest. So let's find the midpoint of DB. I took the average of the x values, and so minus 1 plus 3 divided by 2, and then the average of the y values, 2 plus 2 divided by 2, gives me the coordinate 1 and 2. Then I find the midpoints of the line segment AC. The average of the x values is 0 plus 2 divided by 2. The average of the y values is negative 2 plus 6 divided by 2. And once again, you get the coordinate 1 and 2. So that means that midpoint right there is in fact the midpoint of each of the diagonals of this quadrilateral, and so this quadrilateral is a parallelogram. Don't forget to include the reason that the diagonals bisect each other. So we're repeating this property of a parallelogram. Your homework is on the next page. Good luck and enjoy. Please reach out if you need any help. Tomorrow we're going to go on to more analytical geometry applications.